So Mr. Chakresh Jain did architecture from IIT Kharagpur and started his AutoCAD training and consultancy just after graduations. His initial focus was on application of CAD in architectural design, but soon moved into the partnership with Autodesk and expanded into the software solution for entire building and infrastructure industry in the name of CAD Studio. Mr. Jain served as a founder and CEO of CAD Studio for over 25 years. In 2013, CAD Studio merged with three similar Autodesk partners and formed Capricorn Technology, which is now a leading technology provider for building infrastructure, manufacturing, media and entertainment, education, and government. Capricorn has been consistently recognized by the industry and partnered by various awards. A highly respected voice in AEC industry, Mr. Jain is actively engaged in various positions in IIT Kharagpur Alumni Association, PAN IIT Association, and PSD Chamber of Commerce and Industry. Now I will request Mr. Chakresh Jain to tell us about Capricorn Technologies and its ecosystem, followed by his view on current challenges in infrastructure sector. Definitely, all the audience will be benefited by the experience of Mr. Chakresh Jain. Now I am handing over to Mr. Chakresh Jain for further.
Yeah, thank you, Jay. Shweta, just check I'm not able to share my screen. Jay, probably you'll have to stop sharing your screen.
Yeah, just time.
Everyone, and welcome to this webinar which we are running, and we hope this is not another webinar. COVID has somehow become very famous for webinars, and every day there are hundreds of webinars happening. But on the hindsight, we also see that this webinar has saved us so much of time and effort which we used to do in conducting any of these meetings, and today we are able to have all speakers and participants like yourself from attend across the country. You also see a lot of efficiency gain there. So I'll not take too much of time about talking about Capricorn, but and today we are here to speak about all the other distinguished panelists whom we have. But I just like to leave them with a little bit of problem here. So before we do that, little bit about ourselves. Capricorn, as Jay mentioned, we have been into this business for more than 30 years, and today we are serving more than 20,000 customers across the country in about 10 different locations, and our team size is about 300 people. So we are Autodesk partner. Apart from Autodesk partner, we are what you see here in the box are all construction related and similar design and construction related solution we are partnered with. And we also serve huge set of customers from the infrastructure industry, like we are working with BIM with the DMRC in utilization of BIM for their phase 4. We're working with many other companies and helping them in utilizing these technology for more efficient. Some of the projects also because for our own in-depth understanding, we sometimes do support from a technological perspective in a project. So just to give you an example of one or two projects, in this project for residential development, we did entire underground sewer modeling, and by removing all the clashes, etc., we were able to optimize the slope of sewer system and thereby reduce the digging in the entire facility. Similarly, this is in Qatar, where all they have mandated that all their infrastructure have to be modeled in BIM. So we modeled this NOH intersection twice. First, while it was being designed to remove all the issues, and finally, as it was constructed, we captured the final model with what was executed by the contractor, and now this model is available with the city infrastructure for any future maintenance. Okay, so I like to leave with the panelists on some challenges, and today, and which has been further been highlighted with the current pandemic, is the human population. Now, as a human beings, we have overtaken the entire Earth, and today we are already 7 billion people, and it is expected to become 9 billion by 2050. And we know we are already consuming more than what Earth can provide for. But also, what is a big challenge is this: the growth of this human being is happening disproportionately in urban areas. So most of this growth from 4 billion to 6 billion in next 30 years is going to happen in urban centers. What does that mean? Now that means to provide a roof over each and every person, we need to have huge construction. Now, just to convert those numbers into what is to be done in India, just for an example, we are required to construct almost 800 buildings every day. It may, we don't realize, but this is what is required. 800 buildings are required to be constructed every day in India. And of course, you can see global numbers and in many other countries. Now, not only building, not only just housing, you have to have matching other facilities, and there is a similar huge pressure on providing the infrastructure to connect and to make this building operate. So at a global level, we are required to construct 3,000 kilometers of road every day. 32,000 kilometers of water and sewer pipeline has to be laid. And of course, which means what? That not only we have to increase the speed of what we are doing, but I have to be able to do it at a lesser cost. But today my compliances are also increasing. I need to check them for so many more things as compared to historically. Safety has to be increased, the quality has to be improved. So I cannot imagine any way of delivering all these things without utilization of technology. If we are not going to use digital technology, it is impossible to be able to do that. And what is that technology we need to use to be able to deliver that? And that's for what we are here. We will hear, I like to hear answers to some of these questions from our panelists and experts in this space. So that is the demand side problem. But we also know there is a supply side problem, and that is the construction industry. If you see the brown curve, the productivity in the construction industry has been going down, or if not going down, but if you compare for, let's say, manufacturing industry, which has been able to improve their efficiency, per person productivity has improved in manufacturing. Today they are able to deliver to me a better product, almost at the same price what they were doing, and in high volumes as I need. So today I can go and buy any automobile. Probably the cost of the same automobile has not gone up dramatically in last 20 years. But the same construction project today costs a lot more than if you compare with any consumer good item. And how have they been able to do that? By increasing their productivity. So, but the construction industry, unfortunately, has not been able to do that. So we need to look at how do I increase the productivity. And last slide is what is also expected is that traditionally, before industrialization, we used to get products, or we used to see very good aesthetic value. So if you see entire old temples, palaces, they've been done so well, and their quality is reasonable, but maybe not so functional. The cost, affordability was not there, efficiency was not there. And what industrialization brought, 100 years of industrialization brought, is that it improved functionality, affordability, and efficiency. But today our customer wants best of everything. So they are not just satisfied by having good look, but they also want it has to be functional, it has to be affordable. So how do we meet the dual challenge of high demand, but being able to provide the best of everything in the same time? without leveraging digital technology, I don't see any answer. And that's what, with that, I'll end my presentation and hand over to Jay back. Thank you, everyone.
Okay. Thank you, sir, for your valuable input. And I hope that the participants of this webinar will enrich their knowledge by virtue of, in fact, what the panelist is showing right now. And maybe down the line, we have 4 more panelists. They have they are the domain experts in their respective areas. And I hope that everyone uh, from today's gathering will enhance their knowledge or maybe apply the what informations in provided or the knowledge transfer is given to them. So right now, in fact, next presentation is from Dr. Ravi Shekhar. Uh, just to give the brief about Dr. Ravi Shekhar, Dr. Ravi Shekhar, presently working as a senior principal scientist in CSIR Center Road Research Institute, New Delhi. Dr. Ravi Shekhar did his BTech in civil engineering from JNTU Hyderabad and Masters of Engineering in Transportation Engineering from IIT Roorkee. He has experience of over 20 years in the field of traffic engineering and transportation planning. His research interests are travel time reliability analysis, route choice and mode choice modeling, intelligent transportation system, GPS and GIS application in transportation engineering, highway geometric design and application of soft computing techniques such as artificial neural network in transportation planning. He received his doctoral degree from Kobe University, Japan in the year 2008. He teaches courses on statistical method in engineering and soft computing techniques to the Academy of Science and Industrial Research students. Today, his talk will be focused on the role of technology in planning and design of urban and inter-urban highways. I will request Dr. Ravi Shekhar to share his experience on the subject matter. Thank you very much.
Thank you, sir. Thank you for introducing me in the webinar meeting, the infrastructure needs of tomorrow. Myself as working as a senior principal scientist in transportation planning and environmental division in Central Road Research Institute. Today, I will focus on mainly on the role of technology, planning and design of urban and inter-urban highways in India or in the world anywhere. So the main contents I would like to focus mainly what is a transportation system and mainly any kind of planning, designing, we need data collection methods. So what are the methods and how like traditional planning techniques we are doing and also advanced techniques, how we are considering and the traffic engineering studies and presently what are the main focus areas we are doing in India and also modeling methods. So like modeling methods are very much important for future estimation and generation of the data and also how visualization, mainly the visualization. So without visualization methods like softwares like AutoCAD and other kind of softwares like their use are very much required because the manual methods are time consuming. So we need like techniques, software tools and techniques to reach the targets in time. And what is the future direction? So coming to my Central Road Research Institute, Central Road Research Institute mainly focusing on transportation planning and environmental sciences, pavement material and engineering, geotechnical engineering and landslide hazard management, bridges and structural engineering division, and traffic engineering and road safety. These are the main 5 areas CRRI is focusing to do research and also like solving many government industries and private industries, what are the problem consultancies and research and research projects carrying jointly in India together with any other like agencies. So coming to today's presentation, mainly the elements of transportation system. You see any transportation system, so it is like supply and demand based system. So for example, demand means what? For example, you are every day like the vehicles are coming on a particular intersection or road, like 10,000 vehicles are coming, that is a demand. So supply means whether you required 2-lane carriageway, 4-lane carriageway, 6-lane carriageway, that is the supply side. So coming to external factors, some external factors means, like for example, like rain, fog, and these are coming external factors. These factors influence again on supply and demand. Now users will like understand. Finally, the goal will reach to the users. System users will benefit from the demand and also supply side. So this is like a system. To solve the system, so we need like as a transportation engineering point of view, transportation planning, engineering, and geometry design. These are the three main methods relation to the like transportation engineering point of view. And I will explain how it will be useful, or how it will be the problems how we can solve it in the like present scenario. So coming to data collection methods. So one thing you can say that data collection method. Data collection methods are different. For example, you see like 1990, the data collection method is a purely manual. After 1999, like you see the like topographical techniques, we have used like traditional techniques. 1999, so total station method is came. After that, many other methods, GPS, GIS technology, and also like radar technology, lidar technology. So much technology is coming into the upgrading every like 2 years, 3 years, 4 years. So lot of changes in the electronics field. So but the concept is the same. The design concept will not change. The data collection approach is just different. So you can see that manual methods, videographic technique, intelligent transportation system, global positioning system, and also web-based services. You can see now the post-COVID, like after COVID lockdown, most of the people are depending on the web-based methods. So now come some simple glimpses of some photos I'm sharing here. You see like videography techniques. We are collecting the traffic volume data and also the speed of the vehicles by using the cameras, and also the camera mounted on whether it is connected to the laptop and using some kind of GIS kind of techniques. Also like automatic vehicle license plate collection techniques using the IP based cameras. These are the one of the last 5 years, people are using the IP-based cameras for collection of data collection techniques of traffic volume and also estimation of the speed. Also the vehicle detection methods. For example, vehicle is moving in front of the like radar or maybe any kind of techniques. So it will observe disrupt the ray, and we are counting the wheel base length and vehicle counting and also speed of the vehicle. This kind of techniques we are using currently. And also the main throughout the world, people are focusing about intelligent transportation system. So these three areas, ITS is mainly collection of data and storing centralized processing unit. And again, it is analyzing the data and showing again to the users. These are the three main modules: collection by using the supersonic vehicle detector or maybe video cameras, and data centers, cloud computing techniques, any kind of like you can see here, the information is the processing, and the same information is again sending back to users to warn the thing. For example, road work is under construction, maybe there is an accident. This kind of information given back to the people. So even ITS like well established in the most of the like BRT corridor in India. You can see now a lot of BRT corridors. Particularly for last 10 years, there are a lot of BRT corridors. More than 10 BRT corridors are already operational in India. So these corridors are monitored by the intelligent transportation systems. So like behavioral attitudes, like the behavior and trip information, traditionally we'll use by using the you can see like manual methods, and also you can use the web-based methods techniques, and the questionnaire can be used the Google form. You can ask the questions to the users and circulate among various communities and get the information. Sorry. Another method is the GPS. Like particularly GPS, coming to the like geometric design. So geometric design can be performed with like main parameters are the northing, easting, and elevation. So any kind of map, if you want to develop a map, you need the three coordinates: northing, easting, and elevation. You can see, open the Google map. If you put any cursor on the particular map, you can see the northing, easting, and elevation. So any kind of infrastructure design, any kind of three-dimensional design, we need the data. That data can be either from the Survey of India map, or maybe like a GPS map, or maybe any kind of total station map, total station data, or maybe from ArcGIS data, or maybe from the like any kind of lidar survey data. So methodology is the same, but collection of data, methodology is different, approach is different, but the data collection points, the northing easting elevation, it should be, the approach is the same, but the accuracy depends on what type of instrument you are using. So like accuracy also is a matter. For example, you are doing a feasibility study, DPR study, or maybe any kind of, like it depends on the project purpose. For example, you are doing a rural road design. So you don't need like most accurate LiDAR data. You can use the like a Google Earth data. You can like feasibility, like alignment between city A and city B. You can use Google Earth data, but accuracy is a question. So that's why you have to define what is the objective of your project, and what kind of data can be used. The selection of data is more important. It is also save your time and money. So now some applications done in a CRRI, I would like to explain here. Coming to any kind of traffic plan, transportation planning, traffic engineering is a two different areas. Transportation planning is a macro level kind of data analysis and data collection system, data collection data analysis system. Coming to traffic engineering is a micro level data analysis system. So both are the different. But for example, as a planner, first you have to collect the data at network level and use handle the data and come into the micro level analysis. So like macro level also important and micro level also important. For example, geometry design. Geometry design, if you are doing, is a micro level kind of analysis. For example, you are collecting the data, each individual point on the ground. So that is a micro level information. So for example, you want to make a like transportation network of Delhi or transportation network of any kind of city. So you are collecting the data from the satellite, any kind of information, that is network level kind of information. So that is a maybe the macro level kind of information. So now coming to the like, I would like to briefly explain. So the like coming to the urban criteria, there is the Indian Road Congress. I defined the category of the urban roads. There is a classification of highways, urban roads, urban expressway, arterial, subarterial road, collector state, local state, non-motorized transport, and what are the main design principles of accessibility. So the road, like if you're designing any kind of road, it should be accessible, safe, and comfort, ecology, and also social concerns. So like most of the urban centers are, you can see now that most of the population, car population is dominating many other vehicles. Now people are thinking to public transportation and non-motorized transport. So people are shifting towards the non-motorized transport. You can see now the COVID, like the COVID, before the COVID, people are a lot of public, like personalized vehicles. And now with the social distance and everything, people are restricting the number of trips. So like that in the future, some mechanism is required, like to control the like more number of trips at the using the private transport and reduce the like pollution and safety of the people. So like any kind of urban transportation, so designing is the main mode priority is street design. So the priority is that to save the pedestrians. That is the main priority. So 20 years back, our priority is the main is the like fastness of reaching the destination like within less time. So that is not the thing. Now the design concepts have changed. A priority is the say pedestrian point of view. The design is the pedestrian point of view. So a lot of smart techniques have came already. You will see the smart cities. They are using so many like e-governance, waste management, water management, energy management, urban mobility. So all smart solutions are people are using now. And recently, IRC 86 106 urban road manuals have been revised. The speeds are reduced down, and different. You can see now urban expressway, the plain area, rolling terrain, and mountain terrain. Different speed pattern has been given, and also you can see the templates, like what is the minimum carriageway for the 6 lane width, and also what should be the minimum median width, what should be the minimum like a service road. These are, you can see the typical cross section of 6 lane carriageway. These cross sections are useful to do any kind of geometry design. So if you are doing any geometry design between point A and point B, if you want to collect a 6 lane road, 4 lane road, or 2 lane road, first you have to more clear what is my cross section. So cross sections are the main points for doing the any kind of geometry design. Similarly, the planning of the element, like for example, if you are design, like if coming to the plain road, joining with the two like major and minor road, they need a intersection. So are interchanges. So if the traffic capacity, this will be decided, like defined by the traffic volume. If any traffic volume is more than 10,000 PCUs, you need a grade separate interchange. So like for example, if you have the like land availability, you will go for the like cloverleaf interchanges, and it depends upon the what type of interchanges is required. The designer should should think the benefits of the and availability of land and also traffic volume. Many parameters will decide the grade separated type of the interchanges. Coming to cycle track, now last 5 years in India, more focusing towards the sustainable transportation system, particularly cycle track. In India, most of the people you have seen many like cities like Chennai, like Vadodara, Ahmedabad, Delhi, the cycle population is increasing like 5% to 6%. So we don't have cycle track, but the cycle tracks are also particularly only 1 or 2 kilometers tracks one that cannot be serve purpose. For example, in a point A to point B, you are using the like car. So if you want any person want to use the like cycle any kind of thing, so that cycle track should be a continuous system. It is a network level system. So like designer think the future all after 30 years or 20 years, how my road should be look like. So similarly, grade separator facilities like it is a road subway, elevated carriageway, and under bridge. So every element the designer should seriously think and like keep in mind. So he should be properly design the infrastructure facilities. Then only he will reduce the accidents on the ground. And like traffic calming measures, there are traffic calming measures, whether horizontal measures or vertical measures. These measures will be useful to control the speed of the vehicle on urban corridors. This also the designer have to like see the geometry design in view of the road safety point of view. So coming another area is network level assignment. For example, any like planner, I want to make a like what is my traffic volume on the particular road. So after 20 years, in that case, like current corridor level data cannot useful cannot solve your purpose. As a planner, for example, as a like policy maker, first he has to collect the data. You have to think the network level. For example, what is my like traffic on a particular road at a horizontal base year, and after 20 years, how much traffic will come on the road. So for example, you see any kind of, then only the policy maker will take a suggestion. For example, you see like Eastern Peripheral Expressway, Western Peripheral Expressway in Delhi is designed and they are implemented on ground based on the traffic pattern, traffic volume of the Delhi network city, and they have proposed the like new infrastructure facilities. For example, if you're coming to solving any kind of mining areas, so every problem, transportation problem is completely different. For example, you're like you see the richest mining area is the like Odisha. So people are, for example, you are like government is sanctioning like 10 million tons, 20 million tons to extract the iron ores. These ores will be generated so many trucks. These trucks will use a particular road. So which road should be strengthening or to be widened? So these kind of questions will arise. We want to solve this question of solve these questions. So you need like network level planning and network level designing of the like road. So that's why you see here that one. For example, you have taken mining areas, different area, divided the number of zones, and collect the data and assign the traffic in particular road. What is my base year? So what is my base year traffic volume? For example, you see here, base year the trucks are moving like here. After 20 years, the trucks use some other area. The roads will be like more than the capacity. Then you have to widen the road 2 lane to 4 lane or 4 lane to 6 lane. So accordingly, the agencies will implement the infrastructure facilities on ground. Another area is that application of intelligent transportation system, ITS. So these days, ITS is more help in urban area, not only in urban area, and also it will be useful in the like rural area also. But particularly parking, automatic parking location system, integrated fare collection system, BRT applications, traffic and travel information. These days you see like red light violation jumping. People are using the ITS techniques. So you are now Delhi police also you are like effectively using the ITS techniques to like penalty of the people jumping at the red light signals. So now coming to traffic engineering. Traffic engineering is a different area. The main purpose of traffic engineering is that so you have to identify the behavior of the vehicles. So behavior means the speed of the vehicle, driver characteristics, and also the like carriageway width and this kind of thing. Many kind of this system start with the capacity estimation. For example, I have the 2-lane road. My traffic volume is like 12 vehicles per hour, and my PC is this much. And whether this road will be like sufficient for after 5 years or 10 years something. So the forecasting of the traffic for the future, and if the capacity volume by capacity is more than the like 0.6 or 0.5, in urban area 0.5, in urban areas 0.6, in rural areas 0.5. So then you have go for the new facility. Similarly, like bus transport system, the capacity estimation procedures are different for the different corridor. For example, you are at intersection, the capacity is different, estimation procedure, and you are at the mid block, the capacity procedure is different, and your public transportation, the capacity estimation is completely different. So like all capacity estimation, the fundamental, for example, at mid block, what you will do finally in the traffic engineer point of view, you will estimate the relationship between the speed and density, also you estimate the relationship between the speed and the flow diagram, and you will estimate the capacity of the particular road. Once you estimate the capacity base year, and you will forecast the what kind of infrastructure facility required in the future. Similarly, like it is a single lane road, or maybe intermediate lane road, or maybe 2-lane road, the process is the same. And after that, what you will do, you will use the simulation techniques. For example, my capacity that the particular ground is, for example, I am increasing the traffic flow, more number of trucks are allowed in the daytime. So what will be the capacity? More number of, like, for example, in future, the two-wheeler percentage increases. For example, in the future, the car will be increases 10% or 20%. What is the difference between the present capacity and the future capacity? This kind of can be done by using the micro simulation techniques. So now coming to this, now you can see the road geometry design. This is the one of the area is like required without using softwares these days. That geometry design cannot be possible. For example, you see, like I studied in BTech 19. I passed out BTech from I joined BTech in 1993 and passed out 1997. At that time, we have used, most of the people use dumpy level, theodolite, and plain table for data collection. Now you see any kind of theodolite, dumpy level is there? No. So now people are using the totalization and LiDAR techniques, and also the satellite image techniques, and also the, like, for example, any kind of GIS and GPS kind of techniques. So any kind of methodology for the designing is a simple. So what is your object, whether it's a feasibility, pre-feasibility, feasibility, design. Then you collect the data collection topography, whether it is a topo sheet, Survey of India, satellite data, or maybe like the drones. These are the drones, drones are using for the data collection, LiDAR survey, and then you get the data of these like field data, soil samples and rock samples, because you want to see the CBR value, other kind of thing. What is my pavement thickness? Then go for the data processing, development digital elevation model, and for example, CBR kind of analysis, you have to use the laboratory techniques and develop the element design, horizontal element, vertical element, cross sections, and cut and fill value. Then, for example, if you have any kind of geotechnical kind of issues, short-term measures and long-term measures. For example, you want to, the soil is not good condition, then you have to design in proper way. For example, there is a flyover is coming, so you have to collect the bore samples and other kind of information. So these all information is required to designers. For example, any like minor bridge is coming and major bridge is coming. So all levels are required for the designer to implement in the horizontal element as well as the vertical element. So coming to design, geometry design. So why you need geometry design by using softwares? The software provides a rapid design of the facility. The software is able to visualize the facility in 3 dimensions. The drawings may be rescaled. For example, you have done a design for the 100 kmph, 100 kilometers. For example, you have taken as a like 600 minimum radius occurs. For example, the policy is considered, don't consider the minimum radius is 600. You should do for the minimum is the 800 meter radius. If you are doing manual, it will take a month of time. In the case of the software, you can do in a days of time. So that is means rescaling very easy. So now coming to the market, there are 2 kinds of softwares that are available. One is template based. Template means what? For example, road is made up of different templates. For example, you have the bread is there. For example, cut the bread into the template cross sections. Join all the cross sections is nothing but a template based. So there are the 2 widely used softwares in India. There one is AutoCAD Civil 3D. Another one is InRoads or Open Roads. And the string based means the road is joining of the lines. For example, center line, edge line, and as median line, and as left side and right side. So these based softwares are developed widely using MX Roads and Head software. But India, every software, the motive is to support the data analysis part. But the designer should have the knowledge where to use and which software can be used and what is the benefit of the software and which software is more easier than. So you can take his orientation, but the output is that all the cross sections and also the cut and fill volume and the implementation, the design reports for implementation in the ground. So most of the design software procedure is develop a base map by using the topographical data, digital terrain model, development of horizontal alignment, extraction of profile L section, development of vertical alignment, development of project cross sections template. For example, if you are at 200 kilometers, if it is national highway, some location is the left side carriageway, right side carriageway, left side widening, right side widening. The cross sections is entirely different. So you have to make a representative templates for each location, and these locations you will be noted down, and that will be given to software. The software understand that this section to this section, this template, this section, this channel to this channel, this I am using the survey service road, and this channel to this channel I am using the median width is 5 meters, like different type of the cross section. Then once you develop a roadway model, and then you have to extract cross section. Then after that, you can estimate that the quantity estimation, also report preparation. So some of the we have done for the some high altitudes data, we calculate the leader. You can see here the leader data, and we have developed a contour 0.5 meters interval. So if you calculate the topographical data, and you've done a triangulation, the contours will be done a simple just fraction of seconds. So that is the beauty of the triangles. That is the beauty of the softwares. See the left side, digital elevation model and digital surface model. These are a lot of techniques are coming, which softwares are developed. Software developers are using so many techniques, advanced techniques, and providing facilities to the designer to visualize the condition of the road and also condition of the ground, and also the elevations of the ground profile. These are very much useful to feel at the office level to do the design. So coming to the triangulation, contours. So whatever for example, you have once you develop the digital elevation model. So the development of contour and location of the culverts and the location of the position of the and also the revision, the changes of the curvature of road curvature, and also redesigning, strengthening, widening. It is very much easy. So for example, in one case study we have done for the Simhachalam. So you see existing gray color is the existing road, and there is a deficiency in the horizontal geometry. So because the gradients are very high, for example, you see the here in the gray color existing road, the gradients are very high. It is more than 13%. Then what we did it, we have improved the road. For example, in that case, you need a software. Without software, you cannot able to. You can do manually. It will take much time. So now you can see here we have introduced the 3 point of radius of curvature. For example, first curve, second curve, and third curve. If the length of the curve, length of the road increases, definitely the gradients, vertical gradients will be come down. So this kind of facility of the creation of the rechanging design can be possible. Different alternatives can be possible only through the softwares. So now, for example, other design example, you can see the partially controlled access. For example, if you are bypass you are providing, so how geometry design at the intersections, a T junction, and also the how you can provide the vertical alignment. So you are already the existing ground is like this. For example, you provided the proposed vertical alignment. What is my cut and fill value? These days, automatically, if you lift the string, automatically you can know that how much cut and fill value is coming for the entire corridor or intersection. So now coming to modeling methods, any kind of data. For example, you collected traffic data. So which parameter is main influencing? For example, speed is influencing, or for example, accidents are more influencing, traffic volume influencing. You need some kind of data analysis. That data analysis can be done simply by using the regression analysis. These models can be done using simple Excel-based data analysis. So, for example, you can use a three-dimensional, for example, relation between the speed. For example, you have the BRT corridor. You want to see the speed behavior on the bus lane corridor and also speed behavior on the mixed vehicle lane corridor. These kind of models visualize only can through the modeling part. If you using this kind of visual observation, then only your design can be very easy, and you can understand what kind of facilities to be provided on the ground. So some people some popular more advanced tools, for example, what is the influence of the traffic volume on travel time? Or for example, if the rain is coming, so all the traffic volume is influencing, and what is the finally influence the travel time? This all can be done modeling. Modeling is very much useful for the like for example the designers, and also you can see now recently like GS softwares, AutoCAD Civil 3D, they're providing tools to do the analysis. For example, scatter diagram between one variable to another variable. They're providing a lot of tools. It is advised to the designers or engineers to exposure the providing the latest advanced techniques. So coming to like future challenges. So future challenges are many, but I want to like point out the engineer point of view. 3D visualization method for urban strategies. Highways suggestion for design on an urban side means entire flyover on a particular location. What is influencing on the road? What is influencing on the network? So this can be done by using the three-dimensional visualization softwares. They're already available in the existing. For example, I have developed like Eastern Purple Expressway. So what is the influence? Whether it is influencing, reducing the my noise, reducing the like pollution, or increasing any kind of safety, and what is my like through traffic, Delhi traffic is reduced or increased. So these kind of strategies can be done by using the 3D visualization software. Now you can see that AutoCAD also coming with the 3D visualization techniques, and Civil 3D also providing the 3D three-dimensional visualization techniques. So for example, in the future, people are thinking to develop a express highway, like e-highways. Like you already seen the like railway corridors, but electrification of the railways. Similarly, people are thinking for the what should be the like road design by you considering the electrification of the roads. In that case, the geometry design concepts will change again. So then you have to designer think about the all the elements, infrastructure facilities, what is already in like used in the railway electrification. Similarly, the people has to think. So designing of elements and vertical clearances all come into the picture. The designer should aware of the like upgrade their knowledge for the future changes. Similarly, ITS data. For example, you can see now, particularly from last 5 years, there are a lot of changes in the cloud computing techniques. Data collection is one method. So where you will store the data, but how to use the stored data, how to like implement the analyze the stored data. These are all very much important for the like for the analyzers and also the engineers. But user only need the information. Finally, the user know the, for example, what should be the rainfall tomorrow morning on particular road highway. This is very much important. Similarly, like what is where the accident will occurred in yesterday, or maybe like after half an hour. For example, you want to change the route. These all kind of information will be very much useful. That's why the artificial intelligence techniques and also intelligent transportation techniques are very much like useful. Similarly, artificial intelligence technique. You see now many people are using these days like Google Mini and also like many kind of techniques. These are all are artificial intelligence techniques based development. For example, you're asking Google Mini, play this song. So Google Mini is understanding your voice and playing the song. So how it is possible? They are already trained. So these are artificial intelligence techniques. For example, you see the Facebook. Facebook developed so many kind of softwares and using the artificial intelligence. For example, if you want to open your account, that read your face and it will open your account. Similarly, thumb impression. It's all kind of applications like improved after introduction of the artificial intelligence. Similarly, the signalized system.
Ravi?
You see here, you location.
Yeah,
I will close 1 or 2
yeah,
minutes.
yes.
Yeah. So within 1 minute, I will close.
Okay.
So now coming to autonomous vehicles. Autonomous vehicles means self-driving. So driverless cars. These are all challenging issues. So in that case, these are all linked with the geometry design. So autonomous vehicle conditions, what should be the minimum like lateral distance and longitudinal and all kind of issues will come into picture. Similarly, vehicle classification, collection, and also the storing information. Now throughout India we are doing manually. So this can be manual data collection can be replaced with the automatic vehicle counting and classification systems. So these are the some of the examples. Similarly, like some face recognition systems are already implemented in India, like but these are not full-fledged, but they're like pieceways people are using for the students, or maybe using the AutoCAD users or the Civil 3D users, designers. My sincere advice that please exposure your knowledge and learn the latest techniques which are already introduced by the softwares and apply to the your field. That is my sincere suggestions, and thank you all.
Thank you, Dr. Ravi Shekhar. And now, because Mr. Manmohan Singh Rawat ji is in fact in hurry, he has to join some other meeting. So now the next speaker is Mr. Manmohan Singh Rawat. He's a vice president at AECOM. He holds the master degree in civil engineering with a specialization in transportation engineering from University of Roorkee. He has served Rights Limited and Louis Burgess Group before joining AECOM in 2011. Mr. Rawat, over his 28 years of professional career, has been involved in planning, designing, and coordinations of design, detailing, and tender preparation of a various mega and prestigious highway and expressway projects. So I don't know, his CV is very long, but right now, because we want to listen Mr. Rawat on what in fact they are doing with AECOM. So Mr. Rawat will talk about the latest technology in the field data collections, new concept to accommodate higher design standard within the limits lands compromising the standard, without compromising the standards, and environmental mitigations measures, environmental friendly proposals in infrastructures development. So now I will request Mr. Rawat to.
Hello, can you hear me?
Yes, sir. Please go ahead, because the time is very limited for you. So thank you very much.
Good afternoon to everyone. This is a overview, use of new technology for field data collection. I have around 12 slides only. New concept to accommodate higher design standards within the limit land without compromise standards, environment mitigation measures, and infrastructure and time. There are few sayings, there are three phases of any proposal. One is the conceptual and design stage, one is the execution stage, and one is the post-construction stage. We generally hear at the conceptualization stage or design stage from the client in general, I need it yesterday. You just reach it and you reduce the time, do it fast. I want it as fast as possible. As a matter of fact, we should give more time for the design, but despite that, this is the general phase, I need it yesterday. Next phase comes the implementation stage. Time is of the essence, which is very much written in the document, but there's hardly any importance is given to that. And then the post-construction phase comes, where we do this kind of webinar, seminar, how to reduce the time overrun and cost overrun. And then like this vicious circle goes on, and we are part of that. Manish. Yes. I'm going very quickly, as already it has been discussed by Dr. Ravi Shekhar, and it has been highlighted by Mr. Chakresh Jain, that we have to enter in digital technology. Otherwise, there is no way we can meet the need what I mentioned earlier. I need it yesterday. We have to go as fast as possible. Data collection. There are many this kind of practices are there, and it has successfully implemented in Chardham project in Uttarakhand, where up to the 30-meter, 40-meter height has been made stable. Now we are coming to GeoGrid, because we have to make use of the as much as possible the local material available. Even the nowadays earth is not available, which is the cheapest commodity for any road construction, any infrastructure project. Even for our greenfield project, many of the projects got stranded because earth was not available, which was never given a serious thought that this is at just a 300, 400 rupees cubic meter kind of item, but the item is not available. Even with a 50-kilometer lead, we are not getting the earth. So we have to make existing soil and we have to strengthen the existing soil there at the project itself. Similar kind of study was done. We call it cost-effective technology. Many of the places we have urea factories, and they produce from the thermal power stations. We are using a pond ash and fly ash, and it has become mandatory. This another effort. This kind of effort can be done wherever we are planning any project. If there is any urea factory, that sludge, which is a byproduct of the sludge from the lime from the such factory, can be used for the a clay soil or black cotton soil, highly cohesive soil, and this kind of effort has been done. 9% of lime sludge, which is just like a pond ash what we have from thermal power station. They are ready to dump it up to at least 5 to 10 kilometers wherever we want. So we are getting a very good response. It has been tested in the laboratory. We got from 3% to almost 10% CBR we achieved there. So there are further commercial methods also, but this is the waste which is being used for enhancing the soil property. We are using a byproduct industrial waste, otherwise which requires a large area for precious land for that industry. Converting waste into wealth, preserving, saving natural material, reduction in carbon emission, and cost benefit also. We are comparing with the cement stabilization or lime stabilization. It is much cheaper than that one. Provided such kind of facilities available whenever we are making a design study for a long road, so we should find out if such kind of industries there nearby. Another thing is there, which is though one IRC code is also there, the use of plastic waste, but generally we don't give much or serious thought to this kind of utilization of plastic waste. We have done a research study for this thing, where the plastic waste was 8% of the bitumen by weight. Generally, we can save it by using a plastic waste. So it gives this is also one of the very environment friendly method, and the cost effectiveness, reduction in the consumption of bitumen, contribute to the cleaning operations. And another very interesting part is the rag pickers. Generally, they get around 400 to 500 rupees what they are collecting the plastic waste from the roads and the streets. And as I mentioned, there's a reduction in the bitumen 8 to 10%. Even for the village road where the thin bituminous layers are there, generally premix carpet up to 2% saving is there. The major advantage is the this is the contribution of the cleaning operation. This is a win-win kind of, whether it I will just like to share one successful story. That's as I mentioned, generally once the construction is over, we had a number of seminar workshop how to minimize or eliminate the cost overrun, time overrun. But there is a story which is called the unprecedented before time project also, which is in the just on the outskirts of Delhi. It was the Eastern Peripheral Expressway. It was a greenfield, 135 kilometer, almost all through 6-meter height of embankment. Fully interchange, access control, 6-lane configuration. Cost was around 5,000 crore rupees. Interesting part is that's why it is being called as unprecedented. It was constructed in 500 days. The least count was days, not months, against 900 days. And from 510 days, 10th day, around 40 lakh rupees, very first day toll was started by NHI. It was a win-win proportion for all the stakeholders. NHI starts collecting user fee well before the stipulated time of the project. Contractor receives early bonus, completion bonus, comfort to the commuter and through traffic. Delhi got decongested. We got reduced travel time and substantial saving in the vehicle operating cost. What was the USP? Generally, 90% projects we are seeing that maybe generally running 2 to 3 times of the whatever time period is given. And the story is the project similar mirror image which was done in Haryana. Instead of 3 years, it took 12 years just on the same vicinity. So UST was the client, the NHI, contractors, and authority engineer. All three entities had excellent coordination among them and a mutual trust. We wish such kind of project should be done in future also. It should not remain single project. Thank you, gentlemen.
Thank you. Thank you, Rawat sir, for your valuable inputs, and thank you, Dr. Ravi Shekhar, both from the domain area. Now we are moving to the, in fact, rather than domain, we are now, what Dr. Ravi has pointed out, that technology play important role as far as the executions of any project is concerned, whether it is related to the design, whether it is related to the planning. So now I will request Mr. Devansh Kakkar. So just to know about who is Mr. Devansh. So Devansh is a civil engineer by education with a specialization in infrastructure engineering. Joined Autodesk in the year 2016 as a technical solution specialist for building design solution. He currently leads technical engagement for the Autodesk in North and East India and SAARC region. So Mr. Devansh will talk about more on digital collaborations on large infrastructure projects. As you know, the construction industry is at the critical turning point. No longer can companies settle the fragmented team and disconnected data. It's a time to break down barriers and build a foundation that supports all team members, from general contractors, subcontractors, and owners, though all stages of constructions from design to operation. To keep up with industry demand, new technologies, data management, and shifting workforce, the infrastructure industry is moving to the cloud. Civil engineers can now connect with team virtually anywhere, anytime, break down silos, and transfer data seamlessly throughout the project lifecycle, bringing a new level of connections, efficiency, and integrations to even the largest team and most complex infrastructure projects. Digital technologies are not only changing the way we live in and work, but they are also helping to digitize the infrastructure industry with the power and scalability of the cloud. Team can deliver projects more efficiently and effectively. So, in fact, the COVID-19, I have seen that a lot of organizations is there where they are facing a lot of challenges because the people are there at their home, they are working from home. The collaborations between the different stakeholders was a very difficult task, but now the technology is available, and maybe a better one, which is described by Mr. Devansh Kakkar. He will describe you that what actually is the digital collaboration is and how that will be helpful for everyone, not only the individual, but as a whole organizations, how they can benefit it by this type of collaborations approach which is available. So now I hand over to Mr. Devansh Kakkar for further. Devansh? Yeah, yes. Please. Any issues?
Hi Devansh, we are not able to hear you.
Can you hear me now, sir?
It's clear now.
Okay. Some issue at my end. Okay. Sorry, I didn't know that I wasn't I wasn't mute. So again, I just wanted to reiterate the thanks to all the participants for joining in this session. And without taking too much time, Jaisar gave a brief in terms of what I'm going to talk about, but I'll take a cue from what Mr. Manmohan ji mentioned about the vicious circle of cost overruns and time overruns. And a large part of my discussion revolves around how we can mitigate those scenarios, how we can break these trends and move towards a smoother execution process. So again, Jaisar mentioned about the immediate threat that we faced on 24th of March when everything went into a lockdown phase. All our project data got restricted to our office computers, and because we did not have access to that information, the work entirely stopped, and that caused a big disruption in terms of the project delivery schedules that we had planned. And that's one of the critical reasons why we realized that we need to change the approach of how we execute our projects. We need to change our approach as to how we collaborate on projects, and we need to improve upon our digitization workflows, or probably digitize our workflows so that the information is readily available and accessible. But before I jump onto that, just wanted to give a quick snapshot in terms of the infrastructure, the demand that currently our country faces. I'm just trying to highlight some of the key initiatives taken by the current government and some of the targets, and these are stringent targets that we've set for ourselves. So if you see over the next couple of years, we need to deliver almost 2 crore homes as part of the housing for all policy, which roughly boils down to almost 8 lakh houses per month, delivering 8 lakh houses per month. Similarly, if I see on the infrastructure side, 46 kilometers per day of roads and highways, 111 kilometers per month of railways, which is very steep considering the work process, the methodology we have in place. Where again, and I'll just try and put out some data which has been released by Ministry of Statistics and Planning. Again, in terms of the current trends within large scale infrastructure projects, and when I use the term large scale, I'm referring any project which is more than 150 crores. So almost like 1700 projects, out of which approximately 578 projects are facing a time overrun, and an average time overrun for these projects is almost 38 months, which kind of is almost equivalent to 3 years. So a delay of 3 years. Imagine the cost associated with that. And similarly, on the cost side, almost 400 projects are over budget, which is roughly like 4 lakh crores. And this is just the projects which are being delivered by government. I see on the other side, developers. I see so many owners facing similar trends, similar scenarios. So how do we approach this huge task, this huge challenge, this vicious circle, as mentioned by my previous speaker, and moving to a digital approach, one of the methodologies. Just wanted to highlight some of the key challenges why we face these kind of delays, why we face these kind of budget overshoots. The reason and the prime reason what we see is we have so many people collaborating on a particular project. Decision making becomes very critical when you have so many stakeholders, and you are not able to take the decision unless you have access to the information at the right point of time. The information today is siloed. It's restricted to your office computer, it's restricted to your desktop applications, your design applications, to PDF files. And when I need to take a call, again, I need to have access to that information. And today, that is where we are struggling with. Rework or change orders is another critical aspect, right? So anytime there is a change proposed on a particular project, the entire documentation goes for a toss. Each and every document has to be revisited for accuracy, for consistency, which again delays the entire execution process. So there is team waiting on the side to deliver the project, and still we are coordinating between the design teams and trying to figure out what change needs to be incorporated, which again results both in a loss on the cost side as well as on the time side. There are so again, I am not saying that companies today are not adopting technology. Yes, technology adoption is happening, but then how they are doing it or how they are approaching technology adoption is to address a specific requirement, a specific demand. They are not trying to approach it from a workflow perspective. That is where the struggle begins, where one application does not talk to the other, and there is so much of loss of information that the meaning of the data or meaning of the information that I'm trying to pass completely changes, and that is what is leading us to these kind of scenarios where we are struggling. So how do we mitigate these things? How do we minimize our risk at site? How do we reduce the cost and maintain our budget schedules? And finally, what's the approach to simplifying workflows in terms of collaboration between teams? So at Autodesk, what we are trying to do is trying to leverage the power of cloud that is available and provide a connected BIM workflow, which provides a seamless connection between the designer, between the team executing the job, and finally post the handover to the team who's maintaining that particular facility. Right? And again, even on the design side of it, we've kind of focused our approach to making all our solutions interoperable, such that teams who are collaborating on an infrastructure project, so one particular team is working on the roadway design, another team is working on the drainage design, another team is working on the site development. They can all collaborate and parallelly work on that particular project. Today, what we see, and this is something which I was trying to highlight earlier, is we are using softwares, we are using applications, we are using various different platforms for collaboration. So you see communication happen through WhatsApp on site. You have various open source platforms, Box, Dropbox, SharePoint, FTPs, and again, various different methodologies are being utilized by different organizations. The challenge being that this information is not consolidated. If I need to figure out a particular communication from an external stakeholder, I need to look out for email, and then I need to search for the attachments to that email. Or if he has maybe shared the attachment through FTP, then I need to figure that out on the FTP side. In case the version of the document has updated, then probably I need to recommunicate as to which is the most current version of the document. So again, that's one of the biggest hassles we have today in terms of managing all these documents that are being created, the information that is being created by different design teams. And the simplest solution to this is consolidating that information into a unified environment, and what we term as the common data environment, which is able to aggregate information from various different sources. It probably, again, and I would not like to restrict myself to only Autodesk technology platforms, but even open source platforms, third-party platforms, you can pull in data, you can store data, and then perform all the different tasks that we typically perform during the project execution and project design stage. So just to highlight some of the capabilities, so BIM 360 is Autodesk's native common data environment, and these are some of the critical asks on which it delivers when it comes to digital collaboration. And just to take you through some of the critical workflows, the first thing is it provides that anytime, anywhere access to the stakeholder. You can open up your engineering drawings on your mobile phones, on your web browsers. You do not require the design application to perform reviews. I can do all the markups, I can do all the red lines directly on my Google Chrome. But we've also taken into account that there's a lot of privacy concern when it comes to the engineering data that we store on BIM 360. So there are permissions and access controls which are pre-configured, as well as which can be customized depending on your team setups in terms of defining who has what level of access to this information. It automates the entire version control process. Anytime there is a revision on a particular document and it is published on BIM 360, not only it it's not just and it's BIM based design that you can do. It also has an inherent approval workflow mechanism built into it. We realize through its life cycle, the document exchanges multiple hands. It passes from one stakeholder to the other. So you can pre-configure that review workflow and define the hierarchy of how the document will be shared between the different members, and it will automatically pass on from one to the other. What this now allows is it gives me a great visibility in terms of where the delay is happening. So I can easily come to note that if a document is not moving ahead, then which is the team member who I need to catch hold of, or where the document is currently lying. I have a complete audit report of the document generated, a complete audit history. So even maybe 6 years down the line, if I just pull out the audit report from BIM 360, I can easily find out who recommended a particular change, who made a particular change. So all that information is tracked really well within the BIM 360 environment. And not just from a document management perspective, it allows users who are using various different Autodesk native design applications, Civil 3D for infrastructure design, Revit for building design, InfraWorks from a conceptual planning and master planning perspective, they can collaborate seamlessly. So simultaneously, people can co-author models. They can concurrently work on different aspects of design. So I might have a team focusing on the drainage side. They can carry out this, the drainage design. I might have a team focusing on the landscaping part. They can continue working on the landscape development workflows, the site design workflows. But then they are parallelly co-authoring models. The data is consolidated on site, and as and when that you automatically see it reflect within your design environment, which gives you a much better context in terms of your design. Anytime the changes are made within the model, it is visible to all the stakeholders who are part of that particular project. They can easily visualize the changes that have been made between multiple versions. And finally, all this information from the building site, from the site design, from drainage design can all be consolidated in the InfraWorks environment so that I have a realistic feel. We've been talking about smart cities. So this is essentially a platform which allows me to do city level planning of my infrastructure. Again, a critical part of the workflow is in terms of sharing documents and controlling mechanisms in terms of how the documents are shared externally. How communication happens with external teams. So RFIs and submittals provide me that flexibility where I can define what documents need to be sent out to the different stakeholder in case there is a request for information. I can directly ask my peer to quickly submit that RFI within the platform, and through which everybody has visibility of that RFI. What's the current status, whether it was answered, whether an additional document has been attached to give more details. So the idea is to give a great parity in terms of the overall project progress, right? Where I am, and again, bring in a lot more accountability within the team. Now, tomorrow, nobody can come back and say, my Outlook was not functioning. I didn't know, I checked my email, it went into junk, or probably the attachment was missing. What you are seeing on the BIM 360 platform is the same thing which your peer is going to see. So again, the idea is to unify workflows across team setups, right? And again, you don't need design applications per se. So even if he's using an application which is not installed on your local machines, you can just open it up on your mobile application. You can open it up on your Google Chrome browser. So again, a very good example or a scenario which we discussed up earlier of the COVID situation, where the entire data was restricted to my office computer, right? Had we been sharing data, or had we been hosting data on BIM 360, I could have continued my work without any hassle, without any delay. from home the next day onwards, right? But because the data was consolidated to my office server, I had to put in place multiple mechanisms, set up VPNs, get new servers, and all those things set up for me to start accessing that information and then start collaborating. So that is one key area where I believe collaboration provides a lot of flexibility. And again, it is not just from a design perspective, even from a site workflow perspective. So today, all our inputs on site are happening on paper. And just a very good example somebody pointed out to me earlier was what happens in case of a rain kind of scenario. And I'm on the site reviewing the work on a 2D sheet. And once it rains, my 2D sheet is destroyed and everything goes haywire. In this particular case, all the information is consolidated on a mobile device. And again, you don't face all those hassles. You can do red lines, markups, real-time communication is going to your stakeholders. Each and every comment that you make is timestamped, is user stamped. So again, a lot more context is available to the different team members in terms of reviewing the work. And again, all your paper forms are now available as digital forms. All the input happens through a mobile device, on Android devices, on iOS. And whatever information you are defining can then be backtracked by the project executors in the form of digital dashboards, right? So all the information, because it is all consolidated in a unified interface, we can create dashboards which give us a great visibility in terms of the current status of the project, whether the project is at risk because the issues are not being resolved on time, or because the activities are not completing on time. So I have all that visibility, and as a decision maker, I get a much better I can take a decision much faster in terms of the changes that I need to propose, or the what I need to ensure to see that the project completes on budget and on schedule. Yeah, with that, I am at the end of my presentation, and thanks. I'll just like to thank everyone once again for their time, and I'll just like to hand it over to the next speaker. Thank you, everyone.
Thank you, Devansh, for such a, in fact, interesting presentations, and I hope that audience will be benefited by the collaborative approach, in fact, which everyone can do from their home using the technology. Now, in fact, I'm inviting Mr. Vivek Ramesh. Mr. Vivek Ramesh is a senior technical specialist for civil infrastructure based out of Bangalore. He has over 16 years of Vivek has worked with the customers from various sectors such as GIS, land planning, water, and transportations. And today, Vivek presentation crux is that covering all disruptive technology will be playing a major role in AEC industry going forward. From the convergence of industries to how design automation is helping companies save valuable man hours, he will also touch upon how machine learning and generative design is being to make it mark in the AC industry, stressing on the infrastructure industry in particular. With the steep rise in public infrastructure projects, there is a smarter way to design, build, and operate assets, aiming to enhance the overall efficiency of the system. He shall also cover the aspects of how simulation play a major role in designing resilient infrastructure. So, in fact, all those things which is shown by Dr. Ravi and Mr. Rawat, now you can correlate all those things with the Mr. Vivek Ramesh presentations, that how we can plan and we can design more efficiently. So now I'm handing over to Mr. Vivek Ramesh for further.
Yeah, thank you. Thank you, Mr. Jay. Are you able to hear me?
Yeah.
Okay, thank you. And I hope my screen is visible, right?
Yeah.
Okay. Thank you so much for that. And thank you, Chakresh sir and Jay sir, for having provided this platform to speak about the future of making the architecture, engineering, and construction industry. We will have a sneak peek into what the industry is embracing in the near future or is already embraced. I'm Vivek. I'm a senior technical specialist from Autodesk. Today, I'll be taking you through a journey of sorts for the what it holds for the future of architecture, engineering, and construction. So, for those who are not familiar with who Autodesk is or what Autodesk is all about, if you've passed the most flamboyant of skyscrapers or driven across the most beautiful of bridges or have used some of the most exciting or have driven some of the most exciting cars around and have watched the most involving movies, there is a probability that Autodesk is involved. Yes, we are involved in the space of architecture, engineering, and construction, digital manufacturing, and media and entertainment. So, like Chakresh sir mentioned, we will arrive at the problem statement. In today's date, we are about 7.5 billion people, out of which 3.5 billion people are based in cities. That itself is huge pressure for our infrastructural systems. By the year 2050, I'll probably like to up this number a little bit compared to what Chakresh sir said. I will go extra by 1 billion and say by 2050 there'll be 10 billion people and about 7 billion people will be based out of cities, 20% of the global population. So this itself should give you an idea of how much stress there is on existing infrastructure systems. Just as a sneak peek, to address that, burgeoning demand, we need about 13,000 buildings a day. Say if you take an average of 500 people living or working out of a building, we need about 13,000 buildings a day to be built in order to meet that demand. And in terms of the horizontal infrastructure, we need about 30 times the circumference of the earth in terms of roadways in order to cover the kind of demands coming into with the increased population. So that is the level of demand. So that doesn't address the question of how we are addressing the demands of the future. So just to give you another glimpse of the problem statement, with the current kind of happenings of natural disasters or man-made disasters, there's about $4 trillion worth of assets at risk from damage or permanent damage or temporary damage. So this is the kind of opportunity that people might look at in terms of retrofitting or redesign. We may expect by 2050 that 5 billion of these people, or 50% of the global population, will be waterless. They will have water shortage of some sort. And 90% of the coastal cities are prone to flooding or they have the chances of overrunning by water. So thereby, we have to address the most obvious problem statements. More is inevitable. This is the most obvious thing. There are more people coming into the cities. There's more infrastructure that is needed. We need more for the civilization to survive. Another obvious is that we are running out of natural resources. We're running out of water, we're running out of mineral, we're running out of ore, we're running out of material base, so to speak. But still, we need to deliver the projects better with more projects with lesser resources. So just to give you another glimpse, that 20% of the global force will be retiring in the next few years. So that again creates a pressure for this overall engineering systems. So to tell you about it, infrastructure alone, vertical infrastructure alone constitutes for about 40% of global energy consumption and 25% of water consumption. And infrastructure projects amount to 30% of the global waste. Just imagine the industry is contributing to 30% of the global industry waste, 30% of the material which would have definitely been used for better outcomes. I think Mr. Ravi sir also informed and Mr. Jay sir also informed about the lagging nature of construction. Today, manufacturing is at the helm of productivity optimization. The total economy productivity is somewhere below that. Construction is way below the of the economy. So why is this happening? The main reason that this is happening is construction is not yet fully digitized. We expect a 30% growth in productivity. All the construction activities will be digitized in some manner or the other. So there is the opportunity of better. I mean, we can deliver better projects in our engineering stages. The first thing is 35 years ago, Autodesk introduced AutoCAD the first time in order to address the day-to-day challenges of engineers and architects. That was called the era of digitization, right? 10 years, there was a disruption in technology. We disrupted the drawing board, so to speak. We were technology disruptors of technology. Secondly, in early 2000s, we disrupted the technology. Again, there was a disruption in technology wherein we introduced 3D modeling software in the early 2000s, which later evolved into some terminology called BIM, Building Information Modeling. Again, we are entering, this was called the era of optimization, where we were optimizing designs. The third era that we are currently in is called the era of connection or connectivity, wherein we connect various BIM entities into one, or we have the power of cloud along with the power of BIM. So we will also see in future as to these three eras: era of digitization, era of optimization, era of connection, and the era or the future of making. There are three things that we need to focus on, or change. The things, I mean, how we make things has to change. How we're designing things has to change, how we're making things has to change, and how we are working today in today's world has to change. If you see this building from Schneider, this may appear to be a simple building with a pretty building without any inlaid information inside of it. But if you really dig deep, Schneider has developed a smart building of sorts by sensorizing this building with BIM data as at its base. The base of the model or the intelligence of the model comes from the BIM model itself, wherein Schneider engineers from anywhere in the world can navigate through any of their offices and find out information about any controls that they might want to make, or any information about any building in the world. They'll be able to assess by sensorizing their data or the building. The BIM models will give more and more information with respect to how people are populating the building. Where are the people congregating? Where is the demand on lighting and heating and ventilation? Where is the demand on lighting? Which areas are less prone to Wi-Fi signals? Which areas are more prone to Wi-Fi signals? Things like that, they have information. So smartly, this is a smart building which can eventually turn on and off the systems of HVAC and lighting, whether or not. So we need to also change the way we are making things, right? In today's date, just making designs will not help. Optioneering is one thing that is at the helm of design today. We need to have numerous options. In this case alone, this is a hospital building somewhere in Europe, wherein generative design gives you an idea of how many types of rooms can be fitted inside of a building. This gave an option of 20 to 30 types of buildings which could be 20 types of rooms which can be housed within this hospital building. That is the kind of flexibility that generative design is giving. Mr. Ravi Shankar also informed about the power of artificial intelligence or machine learning, and we need to leverage this technology going forward. So even if we manufacture, we need the convergence of industries to happen. Mr. Rawat also stressed upon pre-stressed construction or prefabricated construction. In today's date, people are manufacturing buildings. They're not constructing buildings, they're manufacturing buildings. This alone will give tremendous impetus to the way we construct buildings. It can happen in a fraction of the time that we are currently doing it. In fact, a building in China was completely constructed in the modular manner that I showed in the video now. In fact, they built a 100-story building in a record time of 18 days, 18 or 21 days, if I'm not wrong, with all the electricals, HVAC systems intact. So they built a 50-story building and they're progressing to build a 100-story building in about 31 days, is what I heard. So with that, we also need to change the way we work. See, people and companies are changing in the way we have to work, or what is the most productive way to work. We need designs to tell us in which is the best formation in an office space that gives us the best formation for best productivity. What is the formation for the best daylight to enter the building? What is the formation to have a balanced work style in a particular building? If you want to have a balance of everything, the spider chart shows you the best combination that generative design can give you in order to have this, these parameters addressed. I only touched upon building aspects now. This can also be applied to infrastructure projects. Generative design and machine learning is coming big and coming hard into the space of civil infrastructure as well. In this case, you can see that a particular layout is being graded. So grading in Civil 3D itself will consume a lot of man hours for the engineer. He needs to do a number of repetitions and iterations. In this case, provided the parameters and provided the kind of environmental concerns that we have, we can optimize the grading designs for with respect to some parameters, with respect to cut fill optimizations, with respect to water runoff, with respect to any of the parameters that we might add. And is unlimited. You can add n number of parameters that you have in mind to optimize designs. In this case, it is giving us an optimized design profile for a cloverleaf design here, or a trumpet interchange in this case. So software is intelligent enough to learn the kind of design intent that you have to move forward. So coming to also, that was from a land and roads perspective. What is the future of rail? Most of you must have heard about the Hyperloop system, right? Virgin Atlantic or Virgin, Richard Branson is coming up with the Hyperloop 1, which is going to be the first of its kind project, which is connecting two airports in France, Charles de Gaulle and Orly airports. The travel time was supposed to be 1 hour. They're planning to bring people from Charles de Gaulle airport in just 5 minutes. That is the kind of time savings, 1 hour to 5 minutes, 55 minutes of time saving. So how did Virgin Hyperloop 1 achieve this result? They were able to do this with a combination of AEC collections that Autodesk offers. In fact, the interwoven workflows that AEC collections offers gave them a lot of flexibility in the way they do design. They also relied on generative design components to optimize the design of the Hyperloop system, the shell itself, and also the carrier which carried people from one block to the other. They've already completed a 1 kilometer long stretch, test in somewhere in Texas, and they've proved it successful as well. Hyperloop is being considered for projects in India as well, connecting Mumbai and Ahmedabad, if I'm not wrong, as the first project that needs to be connected in a Hyperloop system. But that is in the works. So not only that, Mr. Ravi or Mr. Rawat or even Devansh stressed on specific factors. What is that? We need to save time, we need to save cost, we need to see the benefits. These were the three things that came out of all these presentations. So in order to save time, you need to really automate the way you design. The current systems or the current software may not be sufficient enough to get you there in future, right? So you need Dynamo for Civil 3D is what you see on the screen here, is helping engineers automate the way we create rail designs, be it design, placement of sleepers, placement of rails, or placement of gantries, electrical poles, and cabling systems. This can be automated based on parameters that you provide in Dynamo. This can also elevate the way you do production as well. You can get any sort of information from the design drawing that can be extracted into Dynamo, right? Not only that, it can also give you analytics when you design as well. In this case, it's showing an envelope of a rail carriageway, light rail transit system, and you can pass it through the existing design to see the clearance envelope that you need for this design. This can be possible by design automation from Dynamo for Civil 3D. We can see you can clearly do the automation, you can do the animations, and go through the various parametric constraints that you might have in your projects. Coming to the land aspect, we also have fine tunings for intermittent placements of objects or features, such as in this case, you assume urban road. It needs n number of ramps, if you agree with me. It needs ramps for commercial buildings, it needs ramps for residential buildings, it needs ramps just about everything. So software in today's date cannot be able to place intermittent objects like this based on parameters, whether and where you need it. So Dynamo for Civil 3D is helping engineers identify or quicken the design as well, and also it is allowing us to fast track the kind of annotation that we need on the project as well. From a landscape planning and utilities planning also, we can fast track the way we change the utilities design. And in this case, you have 200 kilometers of pipelines running in your city, and at one go you want to change the diameter of the pipe. How much time would it take the engineer to do that? In this case, in one click, you can achieve this by programming in Dynamo for Civil 3D. You need to leverage the power of visual programming and add it to software like Civil 3D, Revit, and so on, to achieve the optimal result that you're looking for design automation. So going to the next, of course, I may not rush into it. This is a project in Norway. They were planning a second line in the all underground Norway between Arna and Bergen. The stakeholders' approvals required a lot of time to approve these projects. So what it required about 4 to 5 years just for the approvals to see all the design aspects. So what a consultant in Norway did was create a virtual reality experience of the entire design model and provide it to the client. The client themselves came to the Norconsult's office and had a look at all the components of that rail transit project, and they approved this project in record time. The kind of byproducts that BIM offers to you is not only visualization but immersive experience. This alone will give you a lot of time savings in terms of how projects are approved. You can Devansh also talked about project overruns, cost overruns. This can be mitigated by leveraging existing technologies based on BIM. Another aspect that Mr. Rawat also and Mr. Ravi also touched upon was the power of 3D modeling in terms of with respect to smart cities. Now, with respect to smart cities, we also need to rely a lot on GIS as we need to rely on BIM. So not only your layout plans, your layout roads or utilities, underground utilities, everything needs to be fed with richer information so that the owner the metadata needs to be richer, so that if you once you provide your designs, the owner should be happy enough to get that data and be able to expand that, on that with respect to maintenance as well. Information is the key. Information is the key to technology, whether it comes to just geographic information systems or building information modeling. The information stays. You need to really enrich the information that relies. So with respect to the kind of amalgamation of GIS and BIM projects, we are having more and more projects which are coming to the client's table as a visual representation rather than 2D drawings. So this alone gives us a lot of headway into the technology as well. Rather than showing you a drawing, I will take you into my model and showcase how my model is progressing. This is the power of building information modeling and 3D modeling as well. This is the penultimate slide that I'm on. So going into the future, where are we headed? As you know, Autodesk and Esri have a partnership right now. Esri has an web app, which allows BIM models to be placed on top of geographical maps. If you can just click, it's like scrolling your Google Maps and clicking on any one particular building. If you click on any one particular building, the authority will have access to all the information with respect to that building. So in this case, you clicked on a building, a hospital building, you have got all the plans and profiles of that drawing inbuilt. You also have the 3D model to be visualized. This is the kind of value that you can provide to the owners. The owners will not have, the truth of the data, the true nature of the data that is available is what is of great value to customers, right? So, going forward, this also gives a lot of, strength for horizontal infrastructure as well, like bridges, flyovers, subways, tunnels. You can just about get information about any infrastructure project in your space and, have them used for maintenance purposes as well, asset management purposes. So coming to the end of the presentation itself, I would want to tell you that, like Mr. Ravi also informed, we need to develop resilient infrastructure. If we don't know how our infrastructure is going to withstand the kind of pressures with respect to traffic, with respect to natural calamities, with respect to any of the unforeseen aspects, we will need to rely on simulations. In this case, he mentioned about multimodal transport, cycle transport, pedestrian transport, transportation systems. In this case, you're seeing a kiosk. Probably it could be at an airport or a metro station. What if there are 3 kiosks malfunctioning? If you see on the right hand side, there are 3 kiosks malfunctioning. What is the kind of clustering that happens owing to that kind of malfunctioning? And you see railway metro platforms or bus station platforms. Are they wide enough? Are they long enough in order to have the kind of crowd coming in? Are we designing infrastructure based on that? We need to see that resilient infrastructure needs simulation of this sort in order to have better design outcomes, right? So having said that, I come to the end of my presentation. In fact, if you have any questions, you are free to ask away. In fact, I would like to leave you with one other generative design example. In this case, it's already a live example. This is a project that Daiwa House created. For one of the European consultants or construction houses. They were asked to provide the optimal layout plan, which gave them a balance of backyard size, solar gain, cost, and variety. So the generative design aspect or project refinery gave them thousands of options before fine-tuning on what the client wanted. It was cost effective, it was profit oriented, it had a lot of variety, and the views were stunning. And it also had a fair share of solar energy coming into the building so that it is well lit. So with that, I come to the end of my presentation. I thank one and all for having sat through this presentation and spending your precious time during this afternoon for the future of infrastructure. Thank you. Jay sir, over to you.
Thank you, Vivek ji. And now, because we are over time now, so just I'm going through few questions which is there. So maybe Dr. Ravi is there. So one question is from Shyam Sundar Khandelwal sir. What is the accuracy of ATCC system for counting and classification? Ravi sir. Hello.
Ravi sir seems to have been muted.
Yes, he's muted. Ravi sir.
You want to unmute as a host, sir?
Yeah.
Yes, sir.
I can. In fact, I can unmute all of them, but I think the controls. Ravi sir, are you there?
Hello, sir.
Yeah, so there's one question from Mr. Khandelwal.
Yeah.
What is the accuracy of ATCC system for counting and classification?
Which system, sir? ABCC.
ATCC
Yeah,
system.
ABCC system accuracy will depends upon the urban, inter-urban road or urban road. For example, in the case of traffic volume is more, the various composition, it will be come down to the accuracy 70%, 70 to 80%. In the case of rural section, the traffic volume is very less and composition also not much more. So it will reach up to the 95%. So it depends upon the headway between the two vehicles and the composition of the vehicle and also the category of the vehicle. For example, sometimes the two vehicles parallelly going, so it's a difficult.
Okay. So another question is from Mr. Raman Kumar. Yeah. Any standard on utility cross sections along with road geometry, geometric ROW for various standard widths?
Yeah, already IRC 106 recent revision provide the standard cross sections for the different roads. Similarly, IRC geometry design for the urban roads. Similarly, rural roads also have the cross sections. So rural road manual is there. So and also IRC Indian Highway cross sections also there. So they can see the cross sections drawings. So for example, in the cross section drawings provided median details and main carriageway, service roads, utility provisions, and also the end of the ROW. Within the ROW, they are given the complete cross section for the plain terrain, rolling terrain, and hill terrain.
Okay. So there's one question from Namrata. What is software used for working of traffic?
Software, traffic?
Yeah.
Traffic counting or what?
For traffic, working of traffic.
I am not clear the question because if working of traffic,
is the one.
if it is a traffic analysis, so like a speed estimation, the software Excel is enough. For example, you want to counting a vehicle counting and video data analysis, some videography techniques are there required.
Ravi sir, there is a software called Vissim as well.
Yeah,
Vissim,
my simulation.
Yeah, Vissim and InfraWorks also has a traffic analyst panel for
so
that.
The question is not clear. They are not asked about the simulation part and the traffic behavior.
Right.
So traffic behavior analysis simulation is required. That is a macro simulation Vsim software. Macro simulation Vsim software. These two softwares are based like PTV Germany developed these softwares. Yeah.
So again, Namrata is asking, this is pure traffic planning and design, but which softwares are used?
Planning, transportation planning at traffic planning level. Vsim software is there, Cube is there, and also other softwares are there. So there are a lot of like MSUN is there. There are a lot of softwares there, but I told in the presentation, depends on the selection of software, depends on the planner or designer.
Okay. So Vivek, sab aapke liye one question is there, that is AutoCAD 2020 software's operating system are much space required. This is not possible to upgrade every time to PC. Hence, can you design minimum RAM and ROM for AutoCAD 2020 onward?
Well, I would like to ask one question. I mean, every technology requires technology, right, to run. If you can, you can't expect the kind of software that is available today, which is really heavy in terms of space, to work on a system which is about 10 years old, right? You definitely can't. I mean, you think about the evolution of phones. We had Nokia phones. We were into smartphones. We were into high-end, flagship phones. So with software, hardware also has to progress. Otherwise, we don't think we can make the ends meet.
Yes. So right now, in fact, if anyone we are there for another 5 minutes. So, okay, there's one question from Mohammed Saif. How many companies do you see resorting to BIM post COVID-19? Also, with the engineering switch from the current construction technology to digital collaborations in construction?
Yeah, I mean, we see a rise of digital technologies, especially on the construction front. If you just want in the sheer numbers front, we have about there is a rise of around 765% in inquiries alone with respect to digital technologies for construction, such as BIM 360, right, during the COVID period, because many of them were struggling at different places. We were working from home, we were working from many other isolated locations. So people needed this technology to make it work. So there is an immense movement of people to take platforms such as BIM 360.
Okay. So I think that is all. And if anybody wants any more informations, you can forward, because our email ID is there. Maybe I'm just sharing you with the informations here. My screen is visible. Yeah, let's stop. So these are the informations, contact detail informations. Anyone can reach anyone in this list. So again, we want to thank everyone who joined us today. And thank you very much for our panelists, especially Dr. Ravi, Mr. Rawat, Mr. Ramesh, and Mr. Devansh, and of course, Mr. Chakresh Jain, to make this successful. So in future also, we are going to organize these type of webinars, because right now, due to the COVID-19 situation, it is very difficult for us to reach individually to the organizations. So it is the right way to communicate, in fact, with our valuable clients. So we are there to assist you. You just drop your any query related to the problem you are facing in handling the software, or if you want any sort of, in fact, assistance from Autodesk, from track record, or in fact, all other ecosystems which is there in and around Autodesk. So we are happy to assist you on those. So thank you very much, everyone, for joining this. And please remain at your home, at isolated places, and be safe. Thank you very much.
Thank you all.
Thank you, and have a great day. Thank you.